Hello, and welcome back to College Algebra, MAT 150. In this lecture, we're going to talk about more examples from our nonlinear inequalities, specifically looking at polynomial inequalities. Let's look at this example. So we want to find the full solution set for the inequality, which, as we remember, the moment we see an inequality, we should think interval solutions. And to find these intervals, we need to split up a number line. So let's just go ahead and pre-make a number line here. Okay? And when we're finding these, when we're finding the number line, what we need to do is we need to find how to split up the number line first. So one side's equal to 0. This is completely factored. So what we do is we look at, first we've got to find the sort of zeros or undefined parts. So we set each factor equal to 0. Which means we can just focus on the inside of the, so if there's an exponent, we can just set the inside equal to 0. X equals -2, x equals 3, and x equals 0. So -2, 0, and 3 is the way that we would partition the number line. Again, this is not the final solution. These are not solutions. These are just helping us split up the number line. The possible solutions are the number lines themselves. So here, here are the intervals themselves. So here, 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 here. So 4 possible solutions, 4 of them. And we got to find out which ones. So we had a table last time. So let's look at the table. So the table is going to be x, so we look at each factor, x squared, x minus 3, and we can bring in the exponents. That's perfectly fine. No exponents for that last one. This full thing is a product of a bunch of different things, so p. And we're going to test values. Okay, we got to pick the values we're going to test. So we got 4 intervals, so we need to pick 4 values. A number between -2 and 0, well, the nice one is -1. Number between 0 and 3, I'm going to pick 1. A number greater than 3, again, pick something overwhelming. It's my advice. You can pick any number you want to the right of 3, though. And then we're going to pick something to the left of -2. So again, I pick something overwhelming, like -100. And so we're going to test these 4 values here. So -100, -1, 1, 100. And then we're going to plug them in and square it. So we're going to plug them into each one. Now, you don't have to really note the exponents unless they're even. So if it's odd, well, an odd to the -1 to the 3rd power is -1 times -1, which is positive, times -1 again is negative. So whatever sign you have in here, it keeps the sign there when it's odd. But when it's even, if it's positive, you square a positive number, it's still positive. If it's negative, you square a negative number, and it's positive. So square factors are always positive, so no matter what, unless you're plugging in 0 itself, or the factor itself becomes 0. But that's not the case in any of these. -100 squared is positive 10,000, but just, again, positive is all we care about. -1 squared, positive, 1 squared, positive, 100 squared, positive. And again, odd powers keep their same sign. So -100 minus 3 is all we have to care about. Well, that's clearly negative. -1 minus 3 is clearly negative. Which is -4. 1 minus 3, we might have to think about that one a little bit, but 1 minus 3 is -2, which is negative. 100 minus 3 is positive. -100 plus 2, negative. -1 plus 2 is positive. 1 plus 2 is positive. 100 plus 2 is positive. And then we just see what the final result is. Positive, negative, negative, whole thing's positive. Positive, negative, positive, the whole thing's negative. Positive, negative, positive, the whole thing is negative. And then positive, 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 the whole thing is positive. Now, what do we actually care about? We want, so the sign here is less than, so we want stuff that's negative. So that's what we do. So we care about the places where it's negative. So it's positive here, negative overall here, negative overall here, and positive here. So our solution set is this interval. Again, this inequality is less than, so strict inequality, so we get parentheses, and this interval where it's also negative. So we get -2 to 0, union 0 to 3. This is our solution set. Now, why do we not just use this whole set? Again, 0 is not included because if you plug in 0 itself, that makes this whole thing 0. And 0 is certainly not strictly less than 0. So 0 does not actually satisfy the inequality, versus everything in here does, and everything in here does, and everything outside of it does not. All right. So we see example 2. There's not much room left for example 2, but if we note, everything from example 2 is almost exactly the same as everything from example 1. X squared minus x times x minus 3 to the third times x plus 2 is less than 0. Here we have x squared times x minus 3 to the third times x plus 2, but instead it's less than or equal to 0. So we have everything the same. So that means that everything from here is basically going to be the same. So we can just recreate the number line and sort of look at what's going on. So we had -2, 0, and 3. And we saw from above that we have positive, negative, negative, and positive. The only difference here is that we have a less than. We also saw that to satisfy the less than part of the inequality, we have this part shaded in. The difference here is that we can have equal to 0. So that means that if we plugged in 0, it is itself included. And then further, if we plug in 3, that's 0. And if we plug in -2, that's also 0. So these three parts that were not part of the inequality before, these numbers now are. And what we have is that since 0 is included, we now have the whole thing. So we have our solution set now, in this particular instance, is it starts at -2 with a bracket, and we go to 0 and we include it, so that means we continue on up to 3. So remember, the solution set includes everything that's included, so we have 0 included and everything up to 3 as well. So we just have this more simplified answer. And this is our final answer for this one. All right, this concludes these examples.